Good evening, everybody, and it's time to go ahead and solve two-step inequalities. Now, much like one-step inequalities, we have two different steps that we have to use to solve this inequality, but we're going to use the rules of inequalities instead of our equations when dealing with it. Well, first of all, we always have to remember we're looking for our variable last. We're going to perform the operations with our variable last. So we're going to do, remember, PEMDAS in reverse. If I do PEMDAS and I put it in reverse, I see that addition and subtraction are the things I do first. So I'm going to go, I see 15 plus over here. That means I have a positive 15. I need a negative 15 to get rid of it. And for those of you tempted to take the number over here and bring it over here, don't do that. Remember, I'm looking for my x to be on one side, all my numbers to be on the other. I need to move all my numbers over here. So the opposite of positive 15 is negative 15. Whatever I do to one side of my inequality, I must do to the other. Now this turns to 0, so I don't have to bring it down, leaving me nothing but 11x. My inequality symbol stays the same. And now 73, negative 73 minus 15 is going to be, well, 3 plus 5 is 8, and 7 plus 1 is 8. So we have a negative 88. For those of you that were tempted to subtract here, do not do that. Remember, we have to go ahead and remember that both of these numbers are negative. This is like I borrowed $73, and then I borrowed 15 more. That means I owe $88. Now, to get my coefficient away from my variable, in layman's term, to get my number away from my letter, I have to divide my number away from it. I know that any number over itself equals 1, so that means now I have 1x left over. My coefficient wasn't negative, so I don't have to turn my symbol around. I can keep it the same. But whatever I divide from one side, I do have to divide from the other. 88 divided by 11 is going to be negative 8. And then it says graph our solution on a number line. But now that I know what x is negative 8, I can create my number line. I will simply put negative 8 here. I don't need to put anything else. And then I got to realize, well, this is a line. So when I said anything else, I don't have to put any other numbers here. Now I see there's a line under my inequality, so that means I'm going to shade in my dot. If there wasn't a line, I would have left it a circle with no shaded in dot. And now all the numbers are less than, see the smaller sign over here, less than negative 8. Well, all my numbers that are less than are to this side of the number line. So I would simply put my arrow pointing in that direction. And we're done with number 19. Let's go to number 21. Once again, I see that I have two steps I have to perform here. The first step is getting this number away from this coefficient and variable. And don't be confused by the number not being in front of it. It's still part of it because it's being divided by it. Over here, we had a number being multiplied to it, right? But if it's underneath, that's a division sign because every fraction is really a division. So now I have to take away 6 because I followed PEMDAS backwards, and that's doing addition and subtraction first. I have to minus 6 from this side as well. And x over 14 comes down. My symbol stays the same so far. And 9 minus 6 is 3. Now I have to find a way to get 14 away from x. Well, again, it's not a negative number, so I don't have to change my symbol. But the only way to get the denominator of 14 away is to multiply it with a numerator of 14. And I'm going to go ahead and just put a 1 underneath. I don't want to divide the x out because I want x to remain. And now I have a number over a number using the butterfly method. Oh, wait a minute. I can cross these out using with 1 there. And now I have x times 1, that's x, and 1 times 1 is 1. Well, so that leaves me with x over 1. And of course, any number over 1 is itself, so I'll simply put x here. Again, I did not multiply or divide by a negative number, so my symbol stays the same. But whatever I divided or multiplied from one side, I had to do the other. Well, I multiplied 14 over 1 over here. So I'll have to multiply 14 over 1 over here. Now you might notice I didn't put an over 1. And that's because any number over itself, as we stated, was itself. Any number over 1 is itself, so I'm just going to leave this 14, because if not, I'll have 14 over 1 times 13, or 3 over 1. Now I need to multiply these together. 14 times 3. Well, 4 times 3 is 12. And carry the 1, that leaves me with 42. So this side I'm going to have 42. And I know now that x equals 42. Or excuse me, x is less or greater than or equal to 42. So let's make our number line again. We're going to put the number 42 here, because that's our number. Again, we have an inequality with a line under it, so I'll make a dot here instead of a circle. If there was no line there, I would simply put a circle. And I know that all the numbers are going to be bigger than 42. 42 is smaller than x. So if they're all bigger than 42, I'm going to shade in my line over here and show my arrow pointing in this direction. And I'm done. Let's go to number 23. A salesperson, Audrey, earns $75 per week plus $5 per sale. Okay? So every week, she earns $75. Then plus $5 per sale. And I'm just going to say $5. I guess I should have put that as S for sale. Sorry. Let's erase that. So it's S equals $5. Make that obvious 5 here. And then per sale. So this week she wants to pay to be at least, her pay to be at least $125, right? And solve an inequality for the number of sales. We need to know the number of sales, but we don't know what it is yet. So we're going to put 5x here. That means however many sales that we have, we're going to multiply it to 5, since she gets $5 per sale. Now we have to come up with an equation. Remember, she wants to earn, okay, she wants her pay to be $125, at least $125. All right, so what is my inequality? Well, first I know that my total has to be on one side, so I'm going to put 125 over here. Next, I know that she gets per week. Remember, this week she wants to earn this. So in 1 week, it's $75. We're going to add it to the amount of sales, which is going to be $5 times X. And all that's going to equal $125. All right, that is our inequality. What's our solution now? Well, let's do our equation over here. We had 75 plus 5x and we got 125 over here. Now the one thing we do have to remember is what inequality sign are we going to have, because it says to make at least this inequality, she wants her pay to be at least this. So that means her pay has to be the same as or more, right? The same as or more. We're not going to have an equal sign here. We have greater than or equal to 125. So let's put that over here, greater than or equal to. And now we start off with getting rid of our addition part. So we're going to get rid of the 75. Whatever I do to one side, I have to do the other. 125 minus 75, that's 0. And 12 minus 7 will be 5. So now I know that 5x, remember 5x here, we're going to bring it down, has to be greater than or equal to 50. Well, this seems pretty easy. I'm going to divide 5 away from x so I can get x by itself. I did not divide or multiply by a negative number, so that is going to stay the same. The symbol will stay the same. And now I have to divide 50 by 5, and that's pretty easy. I know that's going to be 10. And so x is greater than or equal to 10. The solution is x is greater than or equal to 10. The last part is the interpretation. Interpretation I'm going to type out here. Interpretation simply states let's see, Audrey has to sell at least 10 items to earn $125. Well, let's just say, let's rewrite this. Sell 10 items or more. 10. Sorry about that. Audrey has to sell 10 items or more to earn at least $125. So that's it. Number 24 is yours to do. And I will see you in class. Have a good night.